Hello everyone. This is in continuation to our hypothesis testing related problems. The next problem is precision analytics manufactures a wide line of precision instruments and has a fine reputation in the field for quality of its instruments. In order to preserve that reputation, it maintains strict quality control on all its output. It will not release an analytical or analytic balance for sale, for example, unless the balance shows a standard deviation significantly below 1 microgram, says standard deviation below 1 microgram at 0.01 level of significance, means 1% level of significance when weighing quantities of about 500 grams. A new balance has just been delivered to the quality control division from the production line. The new balance is tested by using it to weigh the same 500 gram standard weight 30 different times. This is the number of trials, or I can say sample size. The sample standard deviation turns out to be 0.73 microgram. Should this balance be sold? Means the balance can be sold only if you feel that the standard deviation is lesser than 1 microgram. That is what the company feels, right? So on that basis, we have to take a decision. Now, one thing is very clear that this problem is concerning with population variance. Why? Because here they gave you the population standard deviation as 1 microgram. So let's proceed. Above or the given problem. The given problem relates to test concerning with single population variance. Single population variance means sigma square. So we will use chi-square test. And now the null hypothesis, variance, population variance is 1 microgram. So 1 square will be 1 only. Then alternative hypothesis, it should be less than 1. Means it becomes a left-tailed test because it is focusing on less than 1. Now, the chi-square test statistic will be chi-square cal, that is chi-square calculated value, which is n minus 1 times s square divided by sigma square. N, see, the question has given 30 different times. So n is 30. So 30 minus 1 times s square. The sample standard deviation is given as 0.73. So s square will be 0.73 the square, because s square denotes sample variance here. And this will be 1. So what is the result for this? Let's calculate. It is 29 into 0.73 the square. So 0.73 the square into 29. We get 15.454. Right. Now, when do we accept null hypothesis for a left-tailed test? So we accept H naught for a left-tailed test if chi-square calculated value is larger than chi-square table value at n minus 1 degrees of freedom. Here it is 30 minus 1 at 1 minus of alpha. Here alpha is known to be what? So if you look into alpha is given as 0.01. So 1 minus alpha level of significance. So here 1 minus alpha is 1 minus 0.01, which becomes 0.99. And n minus 1 is 30 minus 1. So it is 29 degrees of freedom. So now let us see what is the chi-square table value. Table value at 0.99 level of significance for 29 degrees of freedom. We can check the tables to find out the value of this. 29 degrees of freedom, 0.99. We get 14.256 from the table. 14.256. This is from the table. Now we can infer, since chi-square cal, which is equal to, what is that? We calculated 15.454. 15.454. It is larger than chi-square tab, which is 14.256. It is a left tail test. So if the calculated value is greater than the tabulated value, we accept H naught. So that is the solution for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.